Okay, everybody, this is section 1-2, composition of functions. Basically, this lesson is all about all different operations you can do with different functions. So you can do all the basic big four, so sum, difference, product, quotient. Basically, what they're just going to have in between the names of the functions, the f and the g, is the operator symbol. So whatever operation symbol is connecting them, those are the operations that you're going to be doing. And just make sure you're keeping track of things like denominators. So like in the bottom one there for division, remember that the denominator cannot be 0. The denominator. That sounded awesome. All right, so let's take a look at a couple of examples. So for the first ones, there's f of x and g of x. You've got a parabola and a line. And what you're going to do is do the operation as. So you're going to make a new function from using those two. So for the first one, there's a subtraction sign in between. So that just means you are going to subtract those two functions. It's really important to put parentheses around, especially when you're subtracting, because you want to make sure that you get the signs correct when you are putting together your like terms. So when I go ahead and do that subtraction, then x is going to be added. So go ahead and put together your like terms. So plus 4x and then minus 7. So when you look at the new function you made, it's degree 2, which means you have just made a new function that's also a parabola. So it just means working with your like terms. So in the next one, we have division. So that means we're going to divide them. And be really careful with things like what can't your denominator be. We know we can't divide by 0, so x is not going to be able to be equal to 7. Remember, set that denominator equal to 0 and solve. All right, so now can you reduce that at all? Can we simplify that? Well, division, the only way you can simplify is if you can divide out a common factor. So I'd have to factor the top. So I'm going to pull out an x and take a look and see if I can do anything. Now, those don't have any binomial factors in common, so there's nothing I can do with that. So you can leave your answer either way. Multiply it out or factored, but that is already simplified. There's nothing you can do. So division. Now we're going to take a look at two new functions. F is a line, 3x, and then g of x is a parabola again, but we're going to do two different operations. So for number 1, we're doing an add. So that means we're just going to add the two rules together. Now for this one, there's really not a whole lot you can do. There's no like terms. Not as big of a deal to use parentheses either, because you don't have to worry about signs or anything. Just rearrange, I would put it in descending order, and you made a new parabola. So that's sum. And then the next one, multiplication. They'll show that either with a times symbol, or you might see a closed dot as well. So we're going to multiply the two together. So parentheses important here to make sure you distribute. So we're going to multiply the 3x out. That would give us 3x cubed minus 3x. So what you made is a cubic function now. So we actually made a new thing. And cubic, if you remember, go something like that, because if you cube a negative number, it's going to be an even bigger negative number. So it's going to go in the opposite direction than what a parabola would do. So basic operations with polynomials works pretty well. All right, let's take a look at the next one. Your parent graphs for these are some of those rational functions. F and G are ratios or fractions. So we got to be careful right from the get-go here. We have some excluded values. What can't x be? So when I look at both of those, x can't be -1 for the first one. X can't be 3 for the second one. So you have to be careful about that when you look at new functions. But they want us to add these two. So 2 over x plus 1 plus 5 over x minus 3. So they want us to do addition. Well, when you have fractions, you have to have a common denominator when you add. So to get a common denominator, I need both of those denominators, so both of those factors. So I'm going to have an x plus 1 and an x minus 3 in each of these. So I just have to take a look back and see what am I missing. So in the first fraction, I'm missing the x minus 3. So this is going back to all this wonderful Algebra 1 stuff. And then this one, I'm missing the x plus 1. So go ahead and multiply top and bottom. Remember, you have to do both because you're multiplying by something that's equivalent to 1. So we don't want to change the value of the function, just want to get a common denominator. So go ahead and multiply that out. So 2x minus 6, 5x plus 5, and we can go ahead and add our like terms together. So that looks like it would be 7x minus 1 over x plus 1, x minus 3. And remember, x can't be equal to -1 or 3 still here because that's two factors that would make the denominator 0. Now, none of those are common factors, so I can't reduce the fraction, but I could do this if I wanted. And can you see what I did there on the bottom? I just multiplied out those two binomials, and that would be fine too. Either of those answers are great. So you made a new function out of these two rational functions by adding. So add, subtract, multiply, and divide works great. It's a nice way to create new functions with working with rules. All right, our new operation. So this is one that you haven't seen before. It's called composition of functions. When you think of the word composition, I want you to think of the word substitute. You're doing a substitution. So it has a new operation symbol, and I'm going to put a box around this. You may want to highlight this in your note sheet as well. This F composed of G, you would say that. It's an F with an open circle. So when you see the open circle, that's your operator symbol for composition. So basically what it means, when you see F circle G, it's not fog, it's composition. It means you are substituting the function g of x into the function f. So you know how to do function substitution or function notation. We did that last week. So like f of 7 or f of 12. You're taking that number 7 or number 12 and substituting in. Well, instead of substituting a number, you're substituting a rule. So I like to say it in words, so maybe that will help clear things up, and we'll do an example. So you substitute the function g of x, that whole rule, into the function f for the x. So you replace the variable x in that rule f with the rule for g. So you're substituting that second function. So the way I like to think of it is whatever comes second in your rule statement, that's what gets substituted. Let's take a look at an example so you can see what I mean. All right, so here are your two functions. You have f of x, which is a line, and you have g of x, which is our friend, the parabola, and you're going to do composition. So we're going to do open circle. So that's what the operation symbol will look like. So f composed, or open circle g, means you're going to take that second function, which is g of x, and you're going to substitute it into f. So the rule for g of x is this whole parabola, x squared minus 2x minus 4. So if you want to think of it symbolically, that's what you're going to be plugging in. So this entire rule, you're going to be substituting in for the x in the function f. Just like you do f of 12, you'd plug in a 12 in place of the x. So that means I'm going to recopy my rule for f. So this rule up here, the line. The rule says 2 times whatever you substitute. So 2 times whatever I'm substituting, which just so happens to be g, and then plus 1. So the rule is 2 times what I'm substituting plus 1. Now to get from here to the end, just go ahead and do distributive property and put your like terms together. So we again made a new function. We made a new parabola by doing composition, so substituting. So whatever comes second gets substituted. Now, same two functions, but let's go the other direction, g of f. That means the f is second. So that means you're going to take the function f and you're going to plug it into g. What that means is this rule right here, this function f, 2x plus 1, is going to get substituted in to the function g. Well, how do I do that? Well, it's just like doing g of 12. You're going to plug in 2x plus 1 into everywhere you see an x in the function g. Well, that means it's going to have to go there. And that function, that whole blob, this whole thing, is going to have to go in for the first x as well, which is squared. So let's recopy that rule g of x. So it says take 2x plus 1 and square it, minus 2 times 2x plus 1, and then minus 4. So you're substituting or replacing it everywhere it appears. And now the rest of it, again, just algebra. So square, that means FOIL, so be careful. And then we distribute. So 4x squared plus 4x plus 1. And I think when we put our like terms together, all we're going to have left is a 4x squared minus 5. So when you look at it, we made a new function. We made a parabola, but it has a little bit different steepness and different vertex from where the original ones were. So composition means substitution. Now, if you look back at your last answer, and this answer, they are not the same. So when you do composition f of g and g of f with the same two functions, you often will not have the same answer. They have very different rules. When you substitute in each direction, they end up to be something different. But there are times where they end up being the same, and we'll look at those when we get to inverses. Okay, so let's do one more practice going back and forth. So we have f of x, which is a line, 3x, and g of x, which is x squared minus 1. Parabola. So f of g, that means you're going to take whatever the function of g is and put it into the f function. So you're going to take that second function and you're going to plug it in place of the x. So that would be 3 times the x squared minus 1. So 3x squared minus 3. G of f, we'll do that in a different color, means you're going to plug the function f of x, which is this 3x, and you're going to plug it into the function g. So it'd be 3x squared minus 1, which if you square that would be 9x squared minus 1. So when you look at the two results, again, you made two new parabolas. They are not equal to each other. So f of g and g of f often are not the same. All right, the last thing I want to finish up with this day one is just taking a look at when is it okay and not okay to actually do composition. So take a look at these two functions. They're very different. They're not like the polynomials we were just looking at. The first one is the square root function, which is the inverse of a parabola, kind of a sideways parabola when you graph it. The second one, if you look at it, g of x equals -2. Think about what that would graph as. Just like saying y equals -2. And that would be a horizontal line, which is definitely a function. If we tried to do f of g for this one, that means you're going to plug in g of x, which happens just to be the number -2, into the function f, which is much more like what we were doing just with regular function notation. But look what happens when you do that. When you plug in a -2, that's not a real answer. That's imaginary. We can't take the square root of -2 and get a real number answer. That is not defined. So the moral to this story here is that you can't just take whatever you want and do composition with it. You have to be careful what those domains are. So when you're doing operations with functions, including composition, we always have to take a look and see if that's something that makes sense. So that's the end of part 1 for section 1-2. The next part will be about iterates.